back to another video. This is section 1.2.1, understanding exponents. So let's start off with a level 1 problem about understanding exponents. So it's important to know just what is an exponent, and basically what it is a repeated multiplication, and you can kind of see that here with the 87s. We have 4 87s being multiplied together. So this type of problem will give you a little box here that you get to fill in with the exponent. And the exponent in this case would be 4, because that's how many times 87 is being repeated. So 87 to the 4th power is how we say that. All right, a level 2 problem, a little more complicated. Now we got a couple different numbers here. But again, the exponent is how many times that number is being multiplied. How many times do we see it? How many times is it being repeated? So let's just go one at a time. I see 19 just once. So that would be 19 to the 1st power. All right. So 23, there's a couple of them. There's 1, 2, 3, 4. So that's going to be to the 4th power for 23. For 49, I again only see one of them, so that's to the 1st power. And for 72, again, just one of them, so to the 1st power. So most of these are to the 1st power in this example, with the exception of 23. Okay, another level 2 problem. So let's see, 37, I've got 4 of those. So that would be written as 37 to the 4th power. 44, we just have one of those, it looks like, so it's just a 1st power. And 49, there's 2 of them, so to the 2nd power. So hopefully you're picking up on this. This is just a shortcut way, really, of writing out repeated multiplication. Rather than, you can see what we have written down below is much more condensed compared to the original. So let's try the next level. This one will get you up to 80, this level. So now it's a little different, a little more complicated in that they don't give you the base, but you're supposed to write the expression using an exponent. Well, we have 6 times 6. That's 2 of them. It's being repeated twice, so we can write it as 6 to the power of 2. And that's it. Don't have to actually calculate it. Another level 3 problem. Okay, this time they give us the boxes again. And now you notice a variable in here. But variables can have exponents just like whole numbers, because a variable is a number, so we can treat it very similar. So there's 1p there, so it would just be to the 1st power. So you don't really do it any differently. I guess I'm going to go backwards this time. 88 to the 1st power, 73 to the 1st power, and we've got 2 of those 5s, so that'll be to the 2nd power. Okay. Now, if you might have to do a problem in level 4, or you might want to. So here is a bunch of 2s. Just got to be careful with counting this correctly. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 2s being repeated. So the base is 2. The exponent is 9. A lot shorter to write it that way. And a level 5 problem, very similar. It is j's though, so it's a variable. So again, though we count it 1, 2, 3, 4, 5, 6, 7, 8. So that's j to the 8th power. And there's another level 5 type of problem. Let's take a look at that real quick. And it's a mix of different variables. And this one, actually, you do have to be a little more careful, in particular when you see the m's here, because we have 2 over here, 2 over here. Just be careful. I mean, multiplication, we could rearrange this if we wanted to and put those m's all next to each other. But we have 4 m's, essentially, so make sure you write m to the 4th power. And then we have two k's, so that'd be k to the second power. If you want to make the dot in between them, that's okay, but you don't need to. And then let's get another color here. The n, there's just one of those, so that'd be n. And when you have this, yeah, you can write it as m to the fourth, k to the second, n, just like this. You could put the n to the power of 1 if you'd like. Also, like I said before, you could put those dots to show multiplication. This is maybe the more advanced way of seeing it without the dots and without the exponent of 1. All right, now it's your turn to give these a try.